Chapter 3, displaying and describing categorical data. So this is one of maybe like 2 chapters that pretty much exclusively deal with categorical. There's not really anything in here that's going to be quantitative. I mean, there might be a little bit here and there, but for the most part, this is just a categorical chapter. So, Ethan, I know you didn't know Mr. Cass, but, well, he hasn't been out here because he's been out, but he'll be the one at the corner in the mornings doing car line. But his thing was always draw a picture. And so with this stuff, the most important thing you do is draw a picture.
Does he have Monday morning calls?
Mr. Cass?
Yeah.
He does every day.
Because Miss Schindler was doing it.
At the corner?
Yeah.
Mr. Cass's dad passed away, so they're on their way out to California for that and to spend some time with his mom. So he'll be out for like 2 or 3 weeks, I think, because they're driving. So they're like in Arizona-ish somewhere, from what I heard today. So, but always draw a picture when it comes to stuff like this. So a couple definitions here. Frequency tables. They records total counts in each category. And I'll show you an example of what this looks like in a minute. So that's a frequency table, but the other option we have is a relative frequency table. Which displays the percent of each category. So the key thing is that frequency tables are counts, relative frequency is percents. So that's going to be your thing of how to tell the difference if you were actually given the table and asked what it was. And obviously, I mean, they'll both, if you had them side by side, would give you the same information, but it's going to look different in how it presents the information to you. So a frequency table we're going to have just 2 columns here. And then we're going to have 3 things under it. So this is going to be dealing with ice cream flavor. So I'm going to color code it because this is the same information we're going to use throughout the, what am I trying to say? Throughout the chapter. We're going to look at a lot of different pictures of looking at all this information. So you might want to get like a couple different colors out to do that. So we're going to look at flavor. And then for the frequency table, we'll be looking at count. And then in the relative frequency table, so we're going to set up the table the same way. We'll be looking at, again, flavor, and then the percent. So we're going to have chocolate, vanilla, and strawberry. I'm gonna say I have a big stash up here as well. Y'all are welcome to use whenever.
You have red and a pencil.
All right, so initially I'm just going to give you information, and then we're going to use this information as we go through the chapter to draw things in different ways and just look at different pictures of the information. So the chocolate one is going to be 18, so that's going to be the count. The percent and the other one is going to be 45%. Vanilla for the count is going to be 10. And then vanilla for the percent is going to be 25%. And then strawberry for the count is going to be 12. And for the percent, it's going to be 30%. Okay, so to an extent, the counts were just kind of pulled out of thin air. Okay, but if you were to add up the total amount of ice cream, basically this is like how many people chose each flavor. So if you were to add up the total amount of those and then divide 18 by the total, 10 by the total, and 12 by the total, that's where these percentages are coming from. So the counts were kind of just pulled out of thin air more or less, but the percentages are coming from this. So, all right, so we're just going to hold that there. We're going to come back to it when we talk about the different kinds of ways to display data. But a couple more definitions here. The area principle is the magnitude of area or says the magnitude of area should correspond to the value it represents. Okay, so all that's saying is that if I am representing the counts, okay, for this ice cream, I should have the chocolate section be the largest and the vanilla section should be the smallest, is really all that that's trying to tell you. So the first representation that we're going to look at are bar charts. So you probably have seen these at some point in math, probably certainly at some point in science. But bar charts can also be relative frequency. So all that's saying is that we can either do counts or percentages, is what that means. They're going to be the same width. And then the bars should not touch. And then the last thing is both axes should be clearly labeled. Is labeled 1L or 2? Okay, I thought it looked weird with 2, but I don't know. I think it looks weird both ways, so I don't know.
I spelled it with 1, but
Okay, well, we're gonna go with 1. All right, so I'm gonna draw a picture of the bar charts off of the information that we have above. So I'm gonna do one for just frequency and then one for relative frequency. So I'm gonna I'm gonna color code those two. So for the frequency one, so that's gonna be my one on the left, I'm gonna do increments of 5, I guess, up to 20. Because my biggest is 18. So you don't have to label all of them, but at least show like what increments you're counting in by putting 2 of them on there. And then part of the label is that this one is going to show that this is a frequency, which will clue me in that I'm talking about counts. And then on the other one, for that side of it, the biggest percentage is 45%. So I'm going to do increments of 10 on this one just because it's not taking up a bunch of space. So that's going to be 50. Obviously the bottom is going to be 0. Let's show that. And so then this one, you could say relative frequency, or to not have to write so much, you could just draw a % over there to indicate that we're dealing with percentages. And then we're going to do a bar for chocolate on each one, for vanilla, and for strawberry. Okay, and we don't want the bars to touch. Now I'm not gonna get a ruler out and make sure that they're the exact same every time, okay, but they need to at least be relatively similar. So the chocolate one, let's see, the count for chocolate was 18. So I'm gonna go up almost all the way to 20. And then just kind of color it in. And on like quizzes and tests and stuff, if you want to color code stuff, I'm okay with that. Stats is the one class where if you use pens on occasion, I'm not gonna take points off for like turning stuff that you're turning in. And then the percentage for chocolate was 45%. See, vanilla, our count was 10. And percent is 25%. And then lastly, strawberry, count of 12. And a percent of 30. So proportionately, they should look, I mean, if you looked at both of them, because one's dealing with count and one's dealing with percentage, you're getting the same information in both of them in terms of like, it's like your ratio of things. So they should look kind of similar in how they're graphed. Unless you're using the exact same increments though, like, again, like a ratio of increments, they're not going to look height-wise exactly the same, but the difference in them should be pretty similar. All right, so that's one way that we can basically draw a picture of our data. Another way we can do it is with a pie chart, which is probably one of the more common ones that you see. I like the pie chart because it shows everything like as one unit together. I feel like you can very clearly see the differences in them that sometimes I don't feel like you can see in other things, but everybody kind of ends up with their preference. A lot of times if I tell you on a quiz or a test to like draw a picture of the data or whatever, you can choose which option you want to use. The big thing is making sure you really label, again, what you are using, because especially when it comes to this one, you're color coding or whatever, but it's important to give like a little mapping, like on a, I don't know, like the world map, you know, like over to the side, it like tells you what things represent, like dotted line, solid line, such and such. You know what I'm talking about?
I think so.
Okay. Well, anyways, you're going to draw a little thing off to the side to show what each thing represents, because that's how we're going to explain what we're working with. It'll make more sense when I draw it. So my words aren't working.
Almost like a key, right?
Yes, thank you. That is the exact word I was looking
Okay.
for. I just could not figure out. I was like, what is the word I'm trying to find here? Oh. All right, so draw a decent sized circle.
You can cheat when you
I showed that to Algebra 1 today, and they were like, whoa. So I was drawing like a square or a cube or something, and they were like, how does it look so good? All right, so I'm just going to draw my key off to the side to show what each thing is going to represent in the diagram, chart, whatever. So this one's a little bit more difficult. You almost need to think about the percentages when you go to insert the sections of your pie chart, because otherwise it makes it a little bit more difficult to know how to divide it up, because it's not obviously being divided up evenly. So chocolate is 45% of your data. So you're almost half of your circle is going to be taken up by chocolate. So do just shy of half of it, I guess, more or less. And then you can either put like a big like C in it and then like kind of just color around it a little bit, or if you're actually using multiple colors, you can just kind of color it in. Actually, I can. Or if you have highlighters and you want to like highlight the colored sections or whatever, that's fine too. But as long as you can see what's what. And then let's see, vanilla was, let's keep going back and looking, 25%, so a little less than a quarter of it. Or right, a little less than a quarter, exactly a quarter of it. And then strawberries, obviously what's left over. So anyways, so there you can see the pie chart. The downside to this is it doesn't show the percentages, it doesn't show the counts. It's just kind of a visual of what is the best option. So, or like if you're looking at who had, you know, which flavor was picked the most, you should be able to tell from here which flavor was picked the most. However, it's not going to tell you what the percentage that was chosen was. So I like the pie chart as a visual person, but in terms of actually trying to get information, the pie chart's usually not the best one. All right. So then the next thing is a contingency, oops, wrong thing, is a contingency table. And these compare different categorical variables also known as a two-way table. Okay, so this one is going to allow us to break down these variables into another category as well. So we're going to do a chart that has 1, 2, 3, 4, 5 columns and 4 rows. So I'm going to draw okay, so then on this top left box isn't getting anything, but over here we're gonna have male and female. So now we're breaking down the flavor choices by male and female. So then these top 3 here in the middle are gonna be each flavor, so the chocolate, vanilla, and strawberry. And then the last column is going to be total, and the last row is going to be totals. All right, so the breakdowns now for the flavors. Let me see. Well, we're using a slightly different count now, but we're doing the same thing just because we're adding in another factor. So, all right, so for chocolate, male is going to be 15, female 20. Vanilla is going to be 5, and then 12. And then strawberry will be 10 and 8. And so then you just total up the amount in each row and each column. It goes in the total box. So 30, 40, 35, 17, 18. And then you do the total that occurred both directions, and those totals should add up to be the same. So this is going to be 70. And then just something to just kind of note in general here, we could also use relative frequency in this chart. Okay, and you do the same thing. All right, so then just a couple labels of things here. The numbers that are in the table itself, okay, so all of these numbers here, the 6 numbers here in the middle for each of the category things. These numbers in the table show conditional distributions. And then the numbers that are in the total row and the total column here are marginal distributions. And just that shows category totals. And then just a couple things about these. In this contingency table, we can use contingency tables to see if there is an association between variables or if they are independent. And so independent, kind of what that looks like, if the distribution of one variable is the same for all categories of another, we can say the variables are independent. So using that table, we'll kind of look at a little bit of an example that goes with this about how to tell if it's independent or not proportionately, because obviously if you look at these counts, I'll go back down in a second. If you look at these counts, it doesn't look like they're the same, right? Because the counts, like each thing isn't the same, but we're looking at proportionately out of the total, are they the same? So. All right, so using the table, the men's distributions, and you will end up doing a lot with contingency tables in this chapter, probably the most out of all of the stuff that we'll do, are. And so we're looking at the total number of men. So the total number of men is 30. So we're going to look at 15 out of 30, 5 out of 30, and 10 out of 30. Okay? So 15 out of 30, 5 out of 30, and 10 out of 30. Okay, and we'll look at what those percentages are in a minute, so we'll get calculators in a minute to actually look at them. And then the women's distributions, I think those ones were out of 40. So women's will be, out of the total number of women's, that's 40, so it'll be 20, 12, and 8. So 20 out of 40, 12 out of 40, and 8 out of 40. So if the proportion for men that choose chocolate and women that choose chocolate are the same, that would be independent. Okay, but we're looking at across the board. So if they're different, then it's not independent. If they're the same, then it is. And they would all have to be. And when I say the same, I mean within like a percentage of each other, because sometimes with rounding, stuff like that, it might be a little bit off. So First one's chocolate, then vanilla, then strawberry. So for chocolate, what is the percentage of men that chose chocolate? 50% were men. How about the women? 50% women. All right, then vanilla. Might need a calculator to do some of these ones.
Oh my gosh. I don't know how good
It's like 17.6.
Yeah. So yeah, I've got it down at 17. So it probably is a little bit of a repeating, but 17%. And then for women, I have this one rounded a little bit, I think, too.
That's 30.
Yeah. 30%. And then the last one, strawberry.
30.
Yeah. We'll just call it an even percent. Make it easier. And women. 20%. So, okay, for chocolate, both were 50%. Okay, but when we look at vanilla and strawberry, they are not the same. They're not really even close to each other. And so, because of this, okay, these indicate these differences. Indicate a lack of independence. Okay, now it doesn't mean that all of them needed to be 50%. It just means for each individual one. So like for vanilla, they both would have needed to be the same, and for strawberry, they both would have needed to be the same to classify it as independent. And so if it asks you to write a conclusion about this, you would say that men are more likely to prefer strawberry than vanilla. Women are the reverse. All right, so we looked at up here, we looked at these bar charts, okay, which each thing had its own individual bar. Now what we're going to look at is a segmented bar chart, which basically each bar is going to have all the possible values on it. So, segmented bar chart. So with this, each bar is a whole. Okay, we use this with the two different pieces of information, how we have like male and female, and then we're going to classify or color a part of it for what is like chocolate, strawberry, and vanilla within the one bar for each for male and female. So each bar is a whole. It's used to compare two different groups. And let's see. bars are the same height basically so we can compare relative frequency, so percentages, not counts. Okay, so we want our bars to be the same height. Okay, each bar is going to have the entire amount in it. So these percentages that we found up here, okay, this is how we're going to, or these are what we're going to use to do our segmented bars. Okay, so we're going to have this. We're going to have male and female. And then each of them are going to have a bar that's the same height. Those are not the same. Those still aren't the same. Okay, now again, I'm not going to get out my ruler and actually measure them, but you want to make them as similar as possible. Okay, and then just a note really quick before we color them in. Be aware of area and scales. It is really easy to misrepresent data using inaccurate graphs or scales. Okay, so we want to stack them up the exact same way. So we want to like match like each flavor next to each other when we do it in the chart. Like don't do strawberry at the bottom of one, but chocolate at the bottom of the other one or whatever. So I would say since chocolate was the same for both, start with that one because then at least you can then see where the other stuff starts to be off comparatively. So 50%. So go about halfway up, and that's where you're going to shade for chocolate. I have to pop back up here and look at the vanilla was 17% for men, 30% for women. And then strawberry is going to be the rest in both of them. And now if you were drawing this for the first time and you hadn't already color coded stuff, I would say draw a key with it to specify what each color represents. But if you have already, since we've had so many places where we've shown what the different colors represent, you don't have to worry about that. Let me look really quick in these. I almost think that this example that I have written down is actually in. Maybe not. let me do the other note thing, and then we might save this one example for tomorrow, because we're getting close on time, and I don't know that we'd be able to finish it. So I mentioned marginal distributions earlier, but I want to actually give a definition for it. Because it can be something that gets confused at times. But a marginal distribution, the frequency distribution of one of the variables from the margin of a contingency table. Okay, so all this means is that it's just giving you the total out of the final column is really all that's saying. It's just a little bit of a fancier way of saying it. It's kind of weird because they don't really talk about these much in the homework problems. They don't really ask you a lot what the marginal distribution is, but on the quiz and test generator thing that goes with the book, they bring it up a lot. So it's one of those things where it's you don't really see it in a lot of homework problems, and then it comes up. So I try to make sure I talk about it before we get there. Anyways. I'm going to go ahead and write the information that you'll need, the problem that we'll do tomorrow, and then that way we can just start with the example tomorrow when we come in. So this is a survey of cars in the school parking lot. Not here or anything. Based on the origin of car. And then the big question that it's going to ask is car origin and driver type independent? Okay, so it's going to be based on student, staff, and then it's going to have the country of origin. So I'm going to go ahead and draw the table, and then we'll be done. So the driver is going to be at the top, student, staff, and then on the side we're going to have car origin. And so that's going to be USA, Europe, or Asia. And for student, it's going to be 107, 33, 55. Staff is going to be 105, 12, and 47, and then the totals at the bottom, it's 195 and 164. So we'll look at that tomorrow and actually finding the percentages, and then go from there. And then I have a few more examples on a worksheet that I'll give you as well.